Hello everybody. So today we're going to focus on the hybrid cloud VPC designs. Now first of all, due to the different natures of the cloud environment, we may have different design best practice for the different size of the customer. So for today's topic, we're not going to focus on the SME customers. Instead, we're going to be looking at those big, large Fortune 500 global MNC customers. A typical global MNC customer, they're going to have multiple regions, head offices. They are going to have multiple region data centers, premises, and they're going to have a global network. They're going to connect them together. They have global file system, global database, etc. Now, they're also going to face, a lot of demand, a lot of traffic due to the nature of the business scalabilities. They're also going to have low latencies, requirement, consistencies, resilience. Now, for today's topic, we'll just talk about three key considerations for those global MNC customers. Number one, transit VPCs. Now, we used to talk about transit gateways and use the transit gateway to connect, customer premises. And use either AWS, Direct Connect, or Azure Express Route back to the cloud. But if you're going to have tremendous of, large amount of the VPCs in the cloud, and also you have different variety of of the head offices and customer the data centers across regions, you're going to have the transit VPCs. So this transit VPC will be act as a shared VPC, but also act as a hub to connect to each VPCs in the regions. And then transit VPC can cross over to not just the premises head office or premises data center, but also they can pairing towards other transit VPCs in the same region or in other regions. So the first figure is illustrate the scenario, which is transit VPC sitting in the middle, connect to the multiple VPC, but also connect to those premises, data centers, and offices. The second diagram or the figures illustrate how the multiple regions can all connected through the trans VPC, and those trans VPC layer, they crossover connect multiple regions, and on the same time they also connect the global head offices or global data centers. Now we have to say transit VPC, that is one of the innovation designs in the hybrid cloud environment, because it's not just improve the scalabilities and by using the hub and spoke models, but also improve the throughput, improve the scalabilities, low down the latencies. It is one of the best practice solution for the large global enterprise. If you're going to have trans VPC routings and trans VPC from one trans VPC to another, you're going to set up the terminals and you're going to link up the terminal BGPs, IBGP, and through the multi-turning protocol, you're going to link them together. And obviously, transit VPC, you still can act as a transit gateway and to connect to the, the customer premises, data centers, or the head offices in each regions. One of the demanding routing protocol, which is you're going to heavily use in the design, is BGPs. So you're going to set up the BGP pairings, prefixed dynamic BGP and autonomous numbers, and pick up the preference paths, and through those dynamic routing protocol, the transit VPC, when they routing traffic either through the same region or across the region, they can make sure you're going to pick up the fastest and also the lowest latencies the paths and forwarding the traffic to. Now, the second part, we're going to be looking at, on the customer side, the orchestrations designs. Now, most of the MNCs, a global MNC customer, they have multiple cloud provider connectivity. They may connect to Amazon AWS or Azure or GCP, or maybe IBM Cloud or Oracle Cloud or etc. other cloud. They have multiple choice, and they're going to host the different application testing DL scenarios through the different cloud providers. And how they're going to get a connector? Imagine if the client have to do the manual switch over from one provider towards another, and also have to figure out how they're going to connect it through the multiple cloud providers manually. That is mission impossible, because it's add up so much complexities to the operations. So one of the things for the service provider that add up is these orchestrations. The providers such as Megapoint, AT&T, and Verizon businesses, they add up multi orchestrations in front of the customer CE routers or H routers. So, for instance, the customer can have maybe in one side they can have 2 or maybe 4 CE routers. It can be Juniper or Cisco, and then through the dual link or quadruple link, they're going through the 2 or 4 different paths, and then through the different paths they connect with the Megapoint, AT&T. Through the diversity, they can connect to the multiple cloud service providers such as AWS, Azure, GCPs, and they can using let's say Direct Connect as a primary to the AWS side to sign a VPN backup as a secondary. To the Azure, they can use ExpressRoute as the primary, side-to-side VPN as a secondary, and etc. And they can switch off the traffic. They can distribute the traffic. But again, heavily use the routing protocol is still the BGPs, because you have to set up the BGPs as numbers, and propagate that BGP routing protocol towards the P router, which is in the upstreams. And also you have to add up the preface list, which is for those community members to do the BGP pairings with the BGP pair. So this is a very typical design for the MNC on the client orchestrations to connect to multiple cloud service providers. The third one, we're looking at a dedicated security inspection PBCs. Now, most of the large organizations, MNCs, they have a lot of traffic. Regardless inbound, internet facing, we call it internet facing in and out, northeast traffic, or cross over the VPC, we call it west-east traffic. So we're going to have a lot of traffic in and out. Previously, we have to using internet gateway and net, and doing a lot of fully mesh configurations, and and also they used to have the legacy sandwich designs for the gateway load balancers, which is really load balancing in front of the firewall, and then also the firewall sending traffic to the load balancer again. That design, it's a legacy. Now with the new protocol we call the Genesis, the vendors such as Palo Alto or Cisco or Juniper or maybe F5, they can using the the Genius protocols to work with global server load balancing, and global server load balancing can do the health check to the multiple virtual instance of the security appliance, virtual security appliance, and do the packet inspections. And also they can make sure, during the high, demanding going up, they can do the auto scalings. Then, if the demand is going down, they can scaling in those, the workloads. Now here's a typical design for the gateway solo balancing. If you look at this figure or diagram here, the traffic coming to the internet gateway as number one. Internet gateway, we are going to add up the default route to the gateway load balancer endpoint. Now, gateway load balancer designs, they have two different points. One is the gateway endpoint, which is really, as the endpoint which gather traffic, from the different subnet, and then forwarding the traffic to the real gateway load balancers. So in this scenario, internet gateway, we are going to route the traffic to the gateway load balancer endpoint. When gateway load balancer endpoint, they can have they're going to have attached to the multiple available zones for the redundancies and for torrents, and then the gateway endpoint, we're going to forward the traffic to the gateway load balancers. Gateway load balancers, we're going to health check the backend instance, the virtual appliance instance. It can be any security vendors, and then based on the load or based on the fairly distribute the inspection traffic, and send to the virtual machines, the virtual appliance on the backend. The virtual appliance, we're going to do the full security check. Again, it's really depends on design. You can do a lot of things. You can do the layer 7, which is what firewall, security check not just TCP sessions, but also check inside of HTTP headers and layers and URL and DNS. But again, if you want to do the cipher, if you want to do really check the header and make sure there's no malwares or other malicious things, you can decrypt the traffic in those virtual appliances, and they can decrypt traffic, inspect the real packet, and make sure everything is sanitized. And then they can encrypt the traffic again and send it back to the gateway load balancers. The gateway load balancer, we're going to forward the traffic to the gateway load balancer endpoint. Again, on gateway load balancer endpoint, we're going to forward traffic to the application load balancers, ARB or network load balancers. And network load balancer, we're going to forward the traffic to those instance or within the workload. So this is a very typical scenario of the designs in the gateway load balancing. And this is for the inbound, which is for the south-facing traffic. The next scenario, we gave the scenarios about east-west, which is between the VPCs. So you're going to have two different VPCs, VPC A and VPC B. And VPC A, they in the subnet, which is 10.104/16, and VPC B is 10.105.16. Some of the applications you need to send the data to from VPC A towards VPC B. So again, the traffic we are going to forward to transit gateway, because transit gateway, which is best practice to connect the multiple VPC, you have to rely on transit gateway to forward the traffic to the crossover and connect and forward traffic to different VPC. That's always step number one. And then transit gateway, we're going to look in the routing table, and obviously so okay, based on the routing, they need to have the cross VPC security inspection. So they're going to forward the traffic to the security VPC. Now, when they forward the traffic to security VPC, they're going to forward to the global server balancing endpoint first. Endpoint, they have attachment association with multiple availability zones, and they're going to, let's say, one endpoint, let's say A, pick up the traffic and payload, and they're going to forward to the real gateway load balancers, and real gateway load balancer will look at the traffic and going to forward to the backend virtual appliance. Virtual appliance, regardless, look at and do the full inspections and make sure everything is no issue with it. And then we're going to return traffic to the gateway load balancer. And gateway load balancer are also going to forward traffic to the gateway load balancer endpoint. And endpoint, we're going to forward to the transit gateways. The transit gateway, we're going to look at the traffic and then forward to the VPC-B. So this is a very typical design for the security VPC for the south, we call the west-east scenarios. So let's have a look on another scenario, which is really based on, again, it's still based on the global server load balancing, but it's just a little bit different. Now, if you look at this diagram, you're still going to have a transit gateway sitting in the middles to connect multiple VPC. You're going to have VPC A, you're going to have VPC B, you're going to have security VPC. They all have the different subnets. On the security VPC, you're going to have a gateway load balancers, and gateway load balancers you're going to connect to the multiple virtual security appliance, and also you're going to have gateway load balancer endpoint, and they're going to connect to those different VPCs. So when the traffic come in, and look at a routing table, and routing table going to forward to the gateway server load balancing endpoint. Endpoint we're going to forward the traffic to those gateway server load balancers in the security VPCs. Security VPC, you're going to look at the traffic and, oh, okay, doing full inspection, I return traffic back to the endpoint. Endpoint, we're going to look at the traffic to see whether or not that is in the, on the virtual routing table, to see whether or not this, goes through transit gate, look at where's the routing going to go, and obviously crossover the VPC, the best practice is transit gateway. We're going to forward the packet to transit gateway. And again, transit gateway, we're going to forward the traffic to the different VPC. So for today's discussion, we look at 3 different, key elements for the large MNC customers. Best practice number 1, we're going to set up a regional and global transit VPCs to remove that full mesh connectivity. Second, we are going to have we're going to have the client-side orchestrations design set up to connect with multiple cloud service providers. The third, we're going to build up a dedicated security VPC. Best practice for the security VPC, we're going to using gateway server load balancers, and through the gateway server balancer and gateway server balancer endpoints, connect and attach a station to different VPC. We can make sure, regardless the traffic is inbound, outbound from internet, or traffic is from different VPC and forwarding towards different VPC, it always going through the sanity check in the security VPCs. And you weren't going to have much impact on the performance. You're not going to have any single point of failure, and you're going to have very good results. Thank you.